So who was our judge? Was it Braden? Braden was our judge? Jake was our judge. So he just called me a jerk. Did he overstep the bounds there? So you think he was actually referring to a calculus problem? Okay, all right. Grace just called out the judge. Thank you, Grace. We measure this in meters per second squared. Has anybody done a weightlifting exercise called the jerk? Okay. That might be the best way for you to consider jerk. But jerk is the rate of change of acceleration. So that would be S triple prime, which is V double prime, which is the derivative of acceleration, which would be J. And we would measure that in meters per second cubed. Now, in this situation, I want you guys to understand that jerk is brought up within your book, but I've never seen it brought up within the AP exam or after this. It might be brought up in a physics course. Right now, if you do take physics, it's not a calculus-based physics course that we offer here at Albert Lee High School. And so that's not a piece that will be applied. However, as you move along, that may be a piece that gets brought up. So let's look at a basic example, and we'll look at one that's a little bit more complex. It says the equation of motion is given by a particle where S is in meters, T is in seconds. Find the velocity of the function, the acceleration at time equals 1, and the acceleration when the velocity is 0. So, letter A. What's the velocity function? Pretty straightforward, right? What's the acceleration function? Now, the problem asks for letter B, says the acceleration at time equals 1. How would I determine that? I would plug in 1. And so, therefore, A of 1 is equal to -6, and we're going to label that as meters per second squared. Because, again, we're measuring acceleration. Is there any point of confusion so far for you? Then let's look at letter C. Letter C says the acceleration when the velocity is 0. What do I first need to determine? When is the velocity 0? So 0 equals 3 times t squared minus 4t plus 4. I just factored it. So 0 equals 3 times t minus 2 times t minus 2. So at what time is the velocity equal to 0? At 2 seconds. Did I answer the question? What is the question asking for? How do I then determine the acceleration? So A of 2 is equal to 6 times 2 minus 12, or 0 meters per second squared. So it turns out that when the function has a velocity of 0 at this point, it also has an acceleration of 0, which is not always the case. Good morning. Any question on that part? Question going once, going twice, 3 times gone. Take out, yes. Yes. Take out your calculator, please, and move on to the next page. It is good for us to try this type of problem because you will be tested on this problem again after Chapter 5 and after Chapter 6 and after Chapter 7. This continually comes back. But what's good is that as we revisit it more, you become better at it. Imagine that. The more often we do it, the better you get. And so here work this, and I would say that you guys will do excellent with this. This will not be any big deal for you. You're an extremely intelligent group. The equation of motion is given by a particle where s is in meters and t is in seconds. What is the velocity at time t? What do I do? What else would you say? V is fine. That's fine. What's the acceleration? Yes. Now it's asking me for when the velocity is positive and when the acceleration is positive. So what I'm going to do in this situation is I'm going to examine the graph. Now we're going to approach this one as though we don't have a calculator, okay? And so as you can see, if I were to factor out a 3t, I would get 6t. Whoop. If I factor out 3t, I end up with 6 minus t. So I'm going to examine that graph real quickly. Where does that graph cross the x-axis? At 0 and at 6. One piece I did not put on here is that t must be greater or equal to 0. We're only going to talk about positive time. I remember to fix it on your worksheet. I did not fix it on your notes. Is this parabola go up or down? It goes down. So that graph tells us when the velocity is positive. When is the velocity positive? Very good. Any question there? That used to be complicated for us. It seems to now be pretty straightforward. Oh, I'm sorry. Yes. Yeah. You could write 0 to 6. That would be fine. That would be fine. No, it would be fine. I will take it either way, and the AP exam usually leaves the answer just like that. Yep. So we would say this. We would say that at 0, the velocity is 0, so it's not positive. So I would say that this would be correct. Okay. When is the acceleration positive? Well, now I need to look at the acceleration graph. And if you consider the acceleration graph, again, you could factor out a 6, and you'd be left with 3 minus t. So what kind of shape does that make? It's a line, and it passes through 3. And does it have a positive slope or a negative slope? Negative slope. So the question is, when is the acceleration positive? From 0 to 3. We're looking at for where this is above the x-axis. And we're not going to say from negative infinity to 3 because we're only going to talk about positive time. Better? Is everybody okay so far? Because for the next problem. Is everybody okay with that? Is there any concern? Because the next part is the new piece. Everybody knows how to do this, right? Okay. Pause for demonstration. So let's answer the question. When is the particle speeding up? I'm simply going to look at a number line, okay? And as I look from 0 to 3 to 6 to infinity, I'll use red for velocity, okay? And I'll use A for acceleration, okay? Is the velocity positive or negative from 0 to 3? It's positive. Is the velocity positive or negative from 3 to 6? It's positive. Is the velocity positive or negative from 6 to infinity? It's negative. Now I'm going to look at the acceleration. Is the acceleration positive or negative from 0 to 3? Positive. Is the acceleration positive or negative from 3 to 6? How about from 6 to infinity? So when is the particle speeding up? That would be when the signs are the same. When are they the same? When is the particle slowing down? And now we culminate with a review from what we started with very first. What is the distance the particle has traveled over the course of 8 seconds? I need to consider the beginning, the change, and the end. At what time does it begin? When does it change direction? 3 or 6? Which is it? Change of direction. Is that when the acceleration is 0 or when the velocity is 0? Velocity is 0. When is the velocity 0? 6. And when does it end? It says 8 seconds. We determine change by looking at the velocity function where it's equal to 0. See that the velocity is equal to 0 at 6. The object is moving in the positive direction. The object is moving in the negative direction. Okay, so we need to figure out the position. How do we figure out the position? Plug it in the calculator. If you plug in, where do I plug it into? This guy right here. If you plug in 0, what do you get? You get 0. If you plug in 6, we got 6 squared is 36 times 9. Oh, now I really want to use a calculator. Okay. Oh boy. Come on, Mr. Calculator. Okay, so we do 9 times 6 squared minus 6 to the third power, and we get 108. So that means that it has a position of 108. And then at 8, we're going to plug in 8 and see what we got then. So 9 times 8 squared minus 8 raised to the third, and I get 64. So that means that the object, it starts at 0, it moves to 108, and it moves back to 64. So the distance would be 108 plus whatever 108 minus 64 is. We all good? Or is that not? Well, why'd you guys tell me 44? Oh, okay. Sorry. I just trusted your answer. Very good. 152 meters. So 108 minus 64 is 44. There you go. Not to trust your answer all the time and make sure I work it out myself. Yes, Rowan. Because the original tells us position. As we are looking for total distance traveled, that requires us to consider position. Not velocity, not acceleration. We want to know location. So this is what tells us location. If you plug in velocity, that will tell us the speed at that time or how fast it's moving. Okay, so we always go back to position. Okay, last one. Good job. What's different here? Yeah, kind of disgusting, huh? So fortunately, we're really intelligent. We can handle it, okay? So it says 3 sine of pi x minus 2 plus 1. If I have to figure out velocity, how do I do that? Derivative, how do I take the derivative of something like that? Chain rule. What's the inside? Pi x minus 2. What's the outside? 3 sine of u plus 1. What is the derivative of pi x minus 2? Pi. What is the derivative of 3 sine of u plus 1? 3 cosine of u. So therefore, our velocity function is 3 pi cosine of pi x minus 2. Looks like I mixed up my t and x variables there. Sorry about that. We'll just go to x. Good job. Way to do it's difficult. So I have to multiply these two together. Yep. We all good? How would I do acceleration? Chain rule again. The inside is pi x minus 2. What's the outside? 3 pi times the cosine of u. What's the derivative of pi x? Pi. What's the derivative of pi, 3 pi cosine of u? We multiply the negative 3 pi times pi. What will that produce? Yep, pi squared. Good. So the question is, when is the velocity positive? Tough to look at that graph, isn't it? So let's consider our calculator. Take out your calculator. We're going to plug both of these functions in. This is very indicative of what you're going to be asked to do later on in this class on a test, and very indicative of exactly what you're going to see when you take your AP exam. And you might say, well, pi squared, I haven't seen that before. Is that realistic? All of these situations are definitely in play, folks. And they might say, you know, we want you to not use your calculator for that portion, but we would like you to use your calculator for this portion. So we go to 3 pi cosine pi x minus 2. And then I'm going to go down to y sub 2, and I'm going to type in the negative 3 pi squared sine pi x minus 2. I'm going to choose to just look at the very first one. I look at the graph. Going to my format here, and I'm going to turn my axes on. And I'm also going to look at my window. Looks like the negative 10 is probably fine, isn't it? But it appears that my x values, I only need to go from 0 to 3, don't I? So I'm going to go from negative 1 to positive 4, and that'll be enough to see exactly what I want to determine. And there's my graph. Real pretty, huh? So, yeah. So I'm going to make a little number line here for myself. And obviously we're going to start at 0. Okay. And I need to look at where the velocity is 0, where it changes. How do I figure out these spots? What do I do? So I can calculate 0. So I'm going to grab this one right here. And I got 0.136. I'll do it again. $1.136. On the AP exam, they will ask you to go to 3 decimal places for your answers. So that's the only reason why I'm writing 3. I normally don't do that. So I can calculate. And we go to 0. And I bet we get 2.136. Lo and behold, we get 2.136. And what do you think we're going to get for the last one? Well, we don't need that, right? Because we're just going up to 3. Everybody okay with that? So as we consider our graph, we know that our graph is below, above, and then at 3.136 it would be there. So that gives us an idea of where it's positive. If you were to state where it's positive, where would you say? Good. Union with 2.136 to 3. When is the acceleration positive? What would I do to determine that? Now I look at the other graph. Press this off, turn this one on. I look at my graph. If I wanted to adjust higher or lower, I could. I'm multiplying by another factor of pi, so maybe negative 40 and positive 40. Maybe that would help me see a better graph. If you would like to, you could do that, and then it would produce this graph. Looks like we have 3 spots here. Can we locate those? Let's locate those. .636. $1.636. Maybe want to take a guess at the next one? Looks like this one starts up, comes down, back, and so forth. So if it asks where it's positive from 0 to 6 or 0.636. Union with what? There is. So you've been able to determine the graphs now. Would you then be able to determine where it's speeding up and slowing down? Yeah, you would. All you have to do is do just like we did for this previous one here. Just look at the overlaps within the intervals, where it's speeding up, where it's slowing down. The fact is that when I created the problem, I didn't anticipate quite this many numbers that came up. I don't think that the AP exam would go that far, but you would be able to have a much better selection for where it's slowing up or slowing down. And then when you do the distance the particle has traveled, same situation. I'm not going to put you through that strain because there's a lot of pieces here, but looking at the graphing calculator and using your 0, that's an important step. So on your worksheet, which you have a full day tomorrow to work on that worksheet, and then you'll have obviously time on Friday, to work as well, and Monday to work on your study guide. So next 3 days are get caught up on all your stuff. Okay. We'll start with a checkpoint. You should be ready to go. Okay. All right. All right. Good job today.